Welcome to this tutorial on physics. Today I'm going to be showing you how to solve these calculations and how to calculate problems. For this one's work, and the formula for work is force equals mass times acceleration. The mass for Boeing 737 is 85,000 kilograms. And the max acceleration for the Boeing 737 is 4.79 millisecond. In this calculator, I'm going to put 85,000 times 4.79, and then I'll give you that answer. And then what I'm going to do is just put 407,150 millisecond in kilograms. And that's for the Boeing 737. For this problem, it's gonna be the force equals mass times acceleration, but for the F-16 fighter. And the mass for F-16 fighter is 9,207.9 kilograms, and the max acceleration for F-16 fighter is 11.7 millisecond. And what I do for this calculation is I'm putting 9,207.9 times 11.7, and I got the final answer of 107,000 or 10,721.9 kilogram, and that's for the F-16 fighter. For the kinetic energy, the formula is 1.5, and then mass times the velocity of the power of the second. And the mass of the Boeing 737 is 85,000 kilograms. And the velocity of the Boeing 737 is 260.62 millisecond. And when I'm putting these the calculations in, I'm gonna multiply 1.5 times 85,000 on the calculator, and I'm gonna divide it by 260.62. So I got 42,500, and then I'm gonna divide that by 260.62. And on my calculator, I should be getting 163.072 joules. Or no, my bad. Millisecond. For the mass for the F-16 fighter is 9,207.9 kilograms. And the velocity of the F-16 fighter is 670.56 millisecond. Now what I'm gonna do on the calculator is put 1.5 times 9,207.9, and then I'm gonna get 4,046,003.95. Now I'm gonna divide that by 260.62. And I should get 17.66 millisecond. For the F-16 fighter. For the potential energy for the Boeing 737, it's 10,668 meters. And the mass for the Boeing 737, it's 85,000 kilograms. And the G for the acceleration is 9.8 millisecond. What I'm gonna do for this one is I'm gonna multiply 10,668 times 9.8, just like this. Next thing I'm gonna do is I'm gonna divide it by 85,000 kilograms. And I got 1.23 meters. Or kilograms. And that's for the Boeing 737. For the F-16 fighter, the potential energy is 9,449 meters. And the mass for the F-16 fighter is 9,207.9 kilograms. And the G for the acceleration is 9.8. Now for this calculation, I'm going to put 9,449 times 9.8. And after that, I'm going to divide it. I got 92,602. Then I'm going to divide it by 9,207.9 kilograms. And my final answer I got is 10.057. And that's for the F-16 fighter. For the work energy theorem, the formula is work equals force times distance. And since we're looking for work, we have to do force divided by distance. And the stopping distance is 1,750 meters. And the force for the Boeing 737 is 66.9. And for the calculation I'm putting in is 1,750 divided by 66.9. And I got 26.16 millisecond. And that's for the Boeing 737. The stopping distance for the F-16 fighter is 910 meters. And the force for the F-16 fighter is also 66.9. And for the calculation, I'm gonna put 910 divided by 66.9. And I got 13.60 millisecond. And that's for the F-16 fighter. The formula for the power is power equals work divided by time. Divided by time. The work for the Boeing 737 is 2,891 joules. And the time for the Boeing 737 is 54.41 seconds. What I'm gonna do is I'm gonna do 2,891 joules divided by 54.41 seconds. And what I got is 53.134. And that's gonna be in watts. And that's for the Boeing 737. And the work for the F-16 fighter is 313.194 joules. And the time for the F-16 fighter is 57.31 seconds. And what I'm gonna do in the calculator is put 313.194 divided by 57.31. And I got 5.4649 watts. And that's for the F-16 fighter.